All right, one last video on the applications of first order differential equations. And this is population growth. Now, in a couple of sections here, section 2.5, I think we will be doing population growth models in much more detail. So right here, this is just an introductory, the basic, simplest assumption of how population might grow. And that is right here. So I'm going to let y equal the population at time t. And let's assume that the rate of change in the population is just some constant times the population. Now that constant would be essentially a combination of birth rate and death rate. So if 3% of your population is being born and 2% of your population is dying, then the difference would be 1% growth or something like that. This is not an unreasonable assumption when there's plenty of resources, lots of food, for instance. If the population you're measuring is like animals or plants, living beings. On the other hand, the population might be the amount of money you have in the bank, and R is the interest rate. Right? So this is a fairly common formula for modeling the population. And it is both first order linear and separable. I will solve it in a separable format. So I'm going to divide both sides by y, multiply by dt. The integral on this side, natural log of absolute value of y. Integral on the right-hand side is r times t plus a constant. Solving now for y, exponentiate both sides. This thing right here, e to the rt plus c is e to the rt times e to the c. But e to the c is a positive constant. If I replace it with c, which could be positive or negative constant, then it allows me to get rid of that absolute value sign. And I get y equals c to the rt, right? This is called exponential growth, or potentially exponential decay if the growth rate is negative. If r is a negative number, then you have decaying population. If r is positive, you have increasing population. But it's exponential growth one way or the other. If I had an initial condition, you'd plug in times 0 here, and the c would turn out to be the initial population. Okay. As I said, we're going to do substantially more of this in a couple, I guess in a couple sections. It is the end of, it'll be this week still, but so that's really all I want to say about population growth at this time.